Hello and welcome. Today we're looking at the table data. Essentially, we're analyzing tables as part of the problem solving and data analysis topic on the SAT math portion. As always, we're going to be looking at 5 questions, explaining them to find the intricacies in this topic so that you can ace the SAT math portion. If you like these videos or found them informative, please be sure to like and subscribe. And with that, let's get started on our first question. Here it is. A biologist conducts a study regarding an invasive species, the Gupta fly, in the city of Porto Alegre, Brazil. The flies were sampled from 3 different parks in 2001 and 2002. Here we have the frequency of sampled Gupta flies in Porto Alegre by year. So we have surveyed parks, Botanical Garden, Ferrao Pilha Park, and Gabriel Nijnik Park from 2001-2002. And we have our information there, but I'm not going to read out all of that, but let's see what we need. We're told that based on the information in the table, what is the approximate probability that a randomly selected Gupta fly sample from 2001 was found in either the Botanical Garden or Ferrao Pilha Park? Well, let's find the total number of samples, which is going to be, adding this up, we get the 2604 plus 2681 plus 2640, which is the total number of samples. We can add that up and we get 7,925. On the other hand, the amount that satisfies the conditions, which is the Botanical Garden or the Ferrao Pilha Park, is 2604 plus 2681, which is going to be 5285, and we divide that and we end up with 66.7%, which is just 67%, and is equal to answer choice C, as we can see here. So that was simply just doing this kind of question by finding the total number of conditions and the number of successes. Basic probability problem, we just took the data from the table and we used that, we turned it into a simple probability problem that was not very difficult to find. And let's move on to the next question. All right, next question, here we are. 2 civil engineers conducted a study of firefighting practices in Africa. They considered 3 different municipalities and classified the types of fire incidents reported by the fire departments in each region. Number of fire incidents by type and municipality. So we have municipality A, B, and C. We have automobile accidents, informal settlements, and structural fires listed in the table above. And then they're asking us, based on that information that we see as a fraction, what is the relative frequency of fire incidents that occurred in municipality C that were not automobile accidents? Or we can add up the number of things in this row of the table, and we get, that's going to be 44 incidents total. 18 of them are automobile accidents, so 44 minus 18 of them, which is going to be 26, which are, we will call them successes, right? In the probability problem, we call them successes. They're just things that fulfill the conditions. They're not automobile accidents. So our answer is then just going to be 26 over 44, which we can simplify that to make 13 over 22. And that's our answer. Looking at our answer choice, that is going to be choice C, and we can move on to the next question. All right, question number 3, here we are. A company conducts a study to understand how employees act during meetings. They observe a total of 300 different meetings and determine whether employees are choosing to multitask or not. The following incomplete table shows the results. So we have employees multitask during, they don't multitask during, and the total number of each meeting observed. We have phone calls, web calls, in-person, and video calls. And let's see what we can do here. Overall, employees choose to multitask during 90% of all the meetings observed. Based on the information above, what is the probability that the employees choose to multitask during an in-person meeting? Well, they chose to multitask during 90% of all of the meetings observed, which is 300 different meetings that were observed. So if 300 meetings were observed and 90% the employee chose to multitask, 90% of 300 is just going to be 270 meetings. And that's going to be the sum of this row right here. So we just need to find everything else in this row, and then we can find the in-person. Well, how do we find the phone calls? Well, we're given the number of total, and we're given the number of ones who don't multitask. So we can subtract that to make 149. The 149 goes right there. It's going to be 149, which means that the 270 total phone calls, or 270 total multitask times, then we're going to subtract that by our 149 that we found, minus the 68, minus 10, and we get 270 minus 149 minus 68 minus 10, which is going to be 43, which is going to be 43 in-person meetings where the employees multitasked. And now we're asked for the information above as a decimal of the probability. So we have 43 ones where they did multitask, and we have 7 where they didn't multitask. So the total is 50. 43 over 50 is going to be 0.9 or 0.86. So that's our answer, 0.86. Now let's move on to the next question. Question number 4, here it is. A sociologist conducts a survey investigating the use of mobile devices and access different types of content in Brazil. The incomplete table below shows the relative frequencies of different age groups that use their mobile devices to read media, watch TV and movies, both read media and watch TV/movies, or neither. So 175 of the people surveyed were 15 to 24, and the other 300 people surveyed were 25 to 65. The correspondent who uses the mobile devices to both read media and watch TV/movies is selected at random. So who do both, selected at random. What is the probability that that person is in the 25 to 65 age group? Well, 64% in the 15 to 24 age group do it. So that's going to be 0.64 times 175, which is going to be 112 people. 112 people. And then here, we need to fill in this table. We have 37 plus 9 plus 11 plus the number of people who do both, which is supposed to equal 100. So we can do 100 minus the 37 minus the 9 minus the 11, and that will give us 43% for what should go in there, which means that 43%, so 0.43 of the 300 is going to do both, which is 129 people. 129 people. The probability is then going to be 129 over 129 plus 112, which we can find to be, using our calculator, that's going to be 0.54 or 54%. Looking at our answer choices, that is choice D, and we can move on to the next question. All right, question number 5, here we are. A box of 450 paper clips contains 300 small paper clips and 150 large paper clips of assorted colors. The following incomplete table below shows the relative frequency of small and large paper clips that are distributed between each color. So we're given small n equals 300 and large n equals 150. We have red, green, yellow, blue, and pink. There are twice as many large green paper clips than there are small green paper clips. If a large paper clip is selected at random from the box, what is the percent probability that it is pink? Right, so first let's fill out the table. So we're told that 16% of the small paper clips are green. So that's going to be 48 small. And there are twice as many large green paper clips as there are small green paper clips. So that are going to be 96, or 48 times 2, 96 large. 96 large. So then what do we do? Well, if 4%, so we have our 4% plus the 12% plus the 14% of red, yellow, and blue, which makes, that's 30%. So 0.30 times the 150 is going to be 45, plus the 96 is 141, which means that there are going to be 150 minus 141, or 9 large pink paper clips. And they're asking us for if a large paper clip is selected at random from the box. So out of that 150, a large paper clip selected at random, what is the percent probability that it is pink? So this is only out of the large paper clips, because we know that it's a large paper clip selected. So out of the 150, the percent probability that it is pink, so the 9, so 9 over 150, which is the 9 over 150 as a percent, which is just going to be 6%. And that is going to be our answer. 6% of the large paper clips are pink. So if we select a large paper clip at random, it's going to be 6% probability that it is pink. And we are done with this topic of table data. Essentially, they are giving us a table, we're analyzing it, and we're using our already known probability skills to figure out an answer. That's all there is to it, and I'll see you next time.